When most people picture Viking innovation, they immediately think of longships cutting through icy seas, or warriors wrapped in furs battling the elements. But the real genius of Norse engineering wasn't only found on water or in war. It was hidden in the very ground they lived on. Long before insulation, HVAC systems or building codes existed, the Vikings created homes so thermally efficient that researchers today are still trying to understand how they managed it with nothing but soil, timber, and a deep understanding of nature. What's fascinating is that the Vikings didn't just build houses, they designed microclimates. These weren't crude huts thrown together for survival. They were deliberate, structured responses to some of the harshest environments on Earth. And somehow, these early Northern Europeans managed to achieve stable indoor temperatures, moisture control, and heat retention in places where modern buildings struggle without a constant fuel supply. The central realization that guided Viking construction was simple. Fighting nature wastes energy, but working with it multiplies your strength. So instead of stacking wood on frozen ground, or building tall walls that would catch every blast of Arctic wind, Viking builders used the land itself as part of their architecture. Their homes weren't placed on the earth. They were integrated into it. One of the most brilliant aspects of their strategy was depth. The Vikings understood that the deeper you go into the ground, the more stable the temperature becomes. Even in regions where air temperatures plunged far below freezing, the earth a few feet down remained relatively constant. So many Viking homes were partially dug into slopes, hollows, or level ground, using soil, nature's oldest insulation, to surround the living space. And then there were the walls. These weren't thin wooden barriers like modern cabins. They were monumental layers of turf, squared blocks of soil held together by the roots of grasses that had grown for decades. Hand-cut slabs were stacked like bricks, heavy, dense, and incredibly effective at trapping heat. In some excavated Viking Age sites in Iceland and Greenland, researchers found turf walls nearly 2 meters thick. Imagine that. 2 meters of compacted earth, absorbing heat from the inside and shielding against the frozen winds outside. That kind of thermal mass meant that once a home warmed up, it stayed warm for hours, even after the fire died down. Modern tests carried out by Arctic engineers show that these earth and turf walls can slow heat loss 3 times better than a modern wooden cabin of the same size 3 times. And the Vikings figured it out without a single textbook. But insulation wasn't the only challenge in the far north. In regions battered constantly by gales, a tall structure acted like a sail, catching wind, shaking under pressure, and leaking heat at every seam. The Vikings countered this with low-profile homes whose shapes mimicked the curves of their boats. Their long, gently arched roofs didn't just look graceful. They redirected the wind, letting it roll harmlessly over the building instead of smashing into it. That roof, though, was more than a shape. It was a system. Viking roofs were layered like geological formations, wooden beams forming the skeleton, topped with birch bark, sod, dried moss, and sometimes even seaweed. Each layer served a specific purpose. Bark acted as a waterproofing membrane. Moss held air pockets that trapped warmth. Turf added weight and insulation. And the surprising layer, seaweed, worked as a natural vapor regulator. Rich in salt crystals, it absorbed humidity, prevented condensation buildup, and kept the interior dry. Today, we'd call it a moisture buffering system. The Vikings simply understood that dry insulation is warm insulation. Inside the house, everything revolved, literally, around the central hearth, placed in the very middle of the main hall. The fire warmed every side of the structure equally. Heat rose upward toward the highest point of the roof, where it gathered, circulated, and slowly radiated downward again. Instead of being funneled out through a tall chimney, warm air lingered inside the home for as long as possible. A small vent or smoke hole at the roof peak let smoke escape without draining all the heat with it. The layout of the interior was another layer of engineering masked as simplicity. People slept on raised wooden benches or platforms that were often filled with straw. Being off the ground mattered. The dug-in floors of longhouses stayed cool and sometimes even slightly damp, pulling cold air downward. Meanwhile, the warmest air naturally floated where the beds were positioned. Without any science vocabulary, the Vikings had designed a perfect convection-based heating system. And then there was the livestock factor, a detail that often surprises modern audiences. In many longhouses, one section was devoted to animals like goats, cattle, or sheep. This wasn't only for convenience or safety. It was physics. Keeping livestock inside boosted the temperature of the home by several degrees, acted as a moisture stabilizer, and even provided indirect ventilation as warm, humid air rose and cooler air sank. The house became an ecosystem of heat, every living thing contributing to the survival of the whole. What's astonishing is how sustainable it all was. Every material used, stone, sod, timber, moss, bone, came directly from the environment and returned to it when abandoned. These homes didn't pollute, didn't require industrial production, and didn't leave scars on the landscape. In fact, centuries-old Viking-style turf homes in Iceland still stand today, performing in some cases better than modern eco-houses that rely on advanced insulation materials. The genius of Viking construction wasn't forgotten either. During World War II, Scandinavian engineers revisited these ancient turf-building techniques when designing winter shelters for soldiers. They discovered that turf-insulated dugouts used half the fuel of traditional wooden barracks. Half the fuel in sub-zero wartime conditions. Once again, Viking thermal engineering proved superior when survival was on the line. But perhaps the most important takeaway is this: Viking building principles are still useful today. Many off-grid homesteaders, Arctic researchers, and sustainable architects borrow directly from these ancient methods. Want a building that stays warm without constant heat? Partially embed it in the ground. Need insulation without plastic foam or fiberglass? Layer turf, moss, and compacted earth. Struggling with humidity in cold climates? Add breathable natural materials like seaweed or straw to balance moisture. Want to cut fuel consumption? Increase thermal mass. Thick walls, thick roofs, thick floors that store warmth. These aren't ideas inspired by nature. They are nature. The most remarkable part of Viking home design isn't that it was effective, it's that it was efficient without waste. No electricity, no manufactured insulation, no powered ventilation. Just observation, adaptation, and generations of learning how to survive winters that would crush the unprepared today. Our homes often fight the environment, blasting heat into cold air, sealing tight boxes that trap moisture, or using fragile materials that degrade quickly under stress. Viking homes worked with the environment, using constants like earth temperature, wind flow, and thermal mass to their advantage. In many ways, These ancient builders achieved something we still struggle with: stable warmth, humidity control, and low energy use in extreme climates. And they achieved it with tools so simple they could be made by hand. So the next time you see a reconstruction of a Viking longhouse, remember? It wasn't a primitive hut. It was a climate control system made of soil and grass, a structure that used physics long before physics was a field of study. A reminder that sometimes the most advanced solutions aren't found in the future, but deep in the past.